Welcome. This is video number 438, and in this video I am going to explain the utility function u. My dear colleagues, ladies and gentlemen, as I mentioned, in this new playlist, which is Advanced Microeconomic Theory, I have already uploaded some videos. That is, video number 434 is on n-dimensional space or non-negative arctant. Then I uploaded one video on the convex sets, and after that the consumption set and the feasible sets were discussed in video number 436, and after that video number 437 was based on the preference relation, and in this video today I am going to explain the utility function u. In modern theory, the utility function is simply a convenient device for summarizing the information contained in the consumer's preference relation, no more and no less. The definition of the utility function is that a utility function representing the preference relation at least as better as any other set. So a real valued function u in positive or non-negative arctant mapping binary relation into a real number is called a utility function, which represents the preference relation given by this binary relation if for all x0 and x1 in non-negative n space or n-dimensional Euclidean space, the utility of x0 is greater than or equal to utility of x1, which implies or which is equivalent to saying that the consumption bundle x0 is at least as good as x1. Thus, a utility function represents the consumer's preference relation if it assigns higher numbers to preferred bundle. If the binary relation greater than or equal to or at least as better as is complete, transitive, continuous, and strictly monotonic, there exists a continuous real valued function u in non-negative arctant mapping preference relation into a real number which represents at least as equal to, and this binary relation or preference relation is given by at least as good as. There are some properties of preferences and utility functions. Let the binary relation at least as good as be represented by a utility function in non-negative arctant that maps real number. Then number one, utility of x consumption bundle is strictly increasing if and only if this binary relation is strictly monotonic. Number two, the utility of a consumption bundle x is quasi-concave if and only if this binary relation is convex. Number three, the utility function is strictly quasi-concave if and only if this relation, that is at least as good, is strictly convex. And then we have differentiability of the utility function, which is often required. Differentiability of the utility function, of course, is a more demanding requirement than continuity. It ensures that indifference curves are smooth as well as continuous. So differentiability is more required than the continuity of the function. Differentiability of the utility function thus requires a stronger restriction on preferences than continuity. For our purposes, we simply assume that the utility representing is differentiable whenever necessary, and the first partial derivative of the utility function of x bundle with respect to xi, that is a particular quantity of x, is called the marginal utility of good I. For the case of two goods, we defined the marginal rate of substitution of good 1 for good 2 as the absolute value of the slope of the indifference curve. That is, marginal rate of substitution of good 1 for good 2 is the negative of the slope of the indifference curve, and that is equal to partial of u with respect to x1 divided by partial of u with respect to x2, and that is equal to the ratio of the marginal utility of good 1 divided by marginal utility of good 2. So this is a brief. Then coming again to differentiability of the utility function, we similarly say that when there are more than two goods, we define the marginal rate of substitution of good j for I as the ratio of their marginal utilities. This I just mentioned. When marginal utilities are strictly positive, the marginal rate of substitution of I for j of the given bundle, consumption bundle, is again a positive number, and it tells us that the rate at which good j can be exchanged per unit of good I with no change in the consumer's utility. It means that marginal rate of substitution basically shows the rate at which one good is substituted for another along the same indifference curve, and then there is no change in the consumer's satisfaction or utility. When u of x is continuously differentiable on non-negative or positive n space or Euclidean space, and preferences are strictly monotonic, the marginal utility of every good is virtually always strictly positive. That is, the partial of u of x with respect to xi is greater than 0 for almost all bundle x and for all I. It means that the marginal utilities are positive. When preferences are strictly convex, the marginal rate of substitution between two goods is always strictly diminishing along any level surface of the utility function. This means that if preferences are strictly convex, then the marginal rate of substitution between good 1 and good 2 will always be diminishing along the same indifference curve. This was a brief discussion about the utility function. Ladies and gentlemen, if you haven't yet subscribed to this channel, kindly subscribe to the channel, and don't forget to click on the bell icon so that you can get regular notification about my other videos that will be uploaded for you. I thank you very much for watching this video. Kindly subscribe various videos of this channel in various WhatsApp groups so that these could reach to the maximum possible number of